Hey friends, welcome to GoodTecher LeetCode video tutorials. This is GoodTecher. In this video, I'm going to talk about how to solve LeetCode coding problem at two numbers. Let's take a look at the description first. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So we are given two linked list inputs. One starts with a head node 2 followed by a node 4 followed by a node 3. Another with a head node 5 followed by a node 6 followed by the node 4. And add them together to generate a result linked list with a head node 7 linked to the node 0 and linked to the node 8. So it's performing the addition on the linked list. We see here it represents the number in a reverse order. So the ones digit on the left and the tens and hundred digits on the right. So the problem is like performing an imitation game. We are trying to imitate the addition operation in math in arithmetic. So we are using linked list to perform the addition. How can we use a linked list to perform the addition operation? So here, please just follow me. I'm going to explain this process and going to talk about some important ideas to solve this problem. So we will have some example here, like we are doing a math. We have a positive number 1, 2, 3, and another positive number 5, 6, 7. And when we want to add them together, we start from the ones digit. So from the ones digit, 3 plus 7 equals to 10. We'll add up to the 10, and we will have a carry here. And we will have a carry to add to the 10th digit. 2 plus 6 add 1, so get 9 here. And 100 digit, that's 1 plus 5, we get 6. So how can we represent this addition operation on linked list? So we need to have a two linked list to represent the input numbers. So the first linked list start from the ones digit. Remember, it's represented in reverse order. So start from the ones digit and then to the 10th digit and move to the 100 digit. And another one start from the ones digit, that's 7, and start to the 6 and 5 here. Now, so we also need to have another linked list to represent the result. That's L3. We will have it to add the ones digit together. 3 plus 7 equals to 10, and we will have keep the one single digit here, that's just a 0, and we will have a carry here, that's just a 1, and we add to the next level. 2 plus 6 plus 1, we get 9 here, and 1 plus 5, that's 6 here. So we generate the result in a linked list. So what's a data structure linked list? So linked list is a linear data structure to store data. We see here linked list have several nodes here. So each node is linked to another node, and underneath each node we will have a place to store the value, also have a reference to point to the next node. So like when we have this node, if we want to represent in a code, we will like to use this way. We have an integer value to store the value. We also have this node pointer to point to the next this node. So how can we convert this process to code to solve this problem? So we can first list how many variables, what variables we need to have to perform such operation. Of course, we need to have, we see here, L3, L1, L2, and L3. They are both list node. So they are pointers to each linked list. So we perform the addition on the ones digit. We move the L1, L2, and L3 on the ones digit. And after finish the addition on ones digit, we move the L1, L2 all to the 10th digit. And similarly, when we perform on the 100 digit, we need to move the L1, L2, L3 on the 100 digit. And besides, we see here sometimes we have a carryover value, so we need to have a integer value called carry to store the carryover value. Besides, I will introduce another one. It's just a dummy node. So dummy node is used to refer to the head of the L3. It's used to refer to the result linked list node. Result refers to the head of the result linked list node. So dummy. So when we representing a linked list, we only need to use a list node to represent. We use head of a list node to represent the whole linked list because each linked node is linked together. So when we have a head node, we already represent the other part of this linked list. So when we want to represent the result linked list, we can just use the head of this result list. So how can we link to the head of the result list? We can just use dummy.next to get the head of the result list. So dummy is a useful technique to solve the linked list problem, and it does not necessary to be included here, but it's good to have to be here. So before we implement this to the actual code, I would like to talk about some cases we need to handle. So as we just said, we have some integers with the same length. So both two input values are at the same length. So these are three digits number. So when we representing in linked list, we have a linked list like this. So we do the math on ones digit, and we do the math on 10th digit. So both L1 and L2 move at the same pace. But sometimes we have two inputs coming from two different lengths. So for example, like this, 12 plus 9. So L1 will have a two list node, and L2 will just have a one list node. So when we do the math here, so at some point L1 list node, we find that there are no more list node on the linked list 2, but there are some still need to keep move forward to move forward on the linked list 1. And besides, we have some situation like 2 plus 9 equals to 11. So in that case, we have a carry to generate another 10 digits of value. So in this case, list node 1 and list node 2 both have only one list node, but our result linked list should generate two list nodes because there's a carry. So we can just add the carry value to the new list node on the linked list. So there are three cases we need to handle. We need to handle them correctly. So let's go back to the problem and let's coding in Java. So here I'm going to demonstrate this exciting coding process. As we just mentioned, we can just start from by introduce those variable we need to have to solve this problem. It's first to have a domino, so we can just initiate domino from any value. So we see here the definition of the list node. So we can just pass into the integer value so that we can initiate an instance of a list node. And I will put some comments here. So domino used to link to the head of the result linked list. And I will have a L3 here. L3 is a pointer on the result linked list. And at the beginning, it should be referred to the same object the domino refers to. And I will have a carry value to keep track of the carry over value. And let's first handle the first situation when both linked list 1 and linked list 2 have some list node remains. So in that case, we generate a new list node on the result list by do the addition from the L1 value and L2 value plus carry value. So we add up them together and then module by 10. Why we need to module by 10? Remember in that case, like this one get 21, 2 plus 9 equals to 11, and 11 module by 10 we get the 1st digit. We only keep the 1st digit at that position, and we need to update the carry here. So carry is just a sum of L1 value, L2 value plus carry here and divide by 10. So carry is 11, like this example, divided by 10 is 1. We'll add up to the next level, that's 10 digit. And we can generate a new node to add to the result linked list. So new node, we initiate this list node with a value that's just a digit value. And we need to update the previous list node on the result linked list. So we link the previous list node on the result linked list so to this new list node. So we add this new node to the result linked list. And we should keep move this L3 pointer to the new node. So next time when we add a new node, so we can start adding new node from the current new node position. So the last position at the result linked list. So here, after this, we should also move the L1 next further. L2 move forward. And after handle this situation, we should go to handle the situation where there's only one linked list has a remaining list node. Like L2 have no more list node to add to the value. So we only have a L1 needs to do. So we still need to have a digit value. So digit value just a L1 value plus carry value and module by 10. And the carry is equal to L1 value plus carry divided by 10, and we also need to generate a new listener node from the digit value here. So new listener node digit value, and we put this new listener node to the result linked list, and we move our pointer to this new linked list node position, and keep move the L1 position one step further. Similarly, on the case when there's only L2 have a remaining list node, we do digit value here, just a L2 dot value plus carry multiply by 10, and the carry is a L2 dot value plus carry divided by 10. And we also need to initiate a new listener node. New listener node with a digit value. And we add this new node to the result linked list. We move the L3 pointer to this new added linked list node, and move the L2 pointer move forward until we find that there are no more listener node remains on the linked list. And one more situation, that is like when we do the math, 2 plus 9 equals to 11, we have a carrier value. So when we have no more L1 and L2, we have no more listener node on both linked list 1 and linked list 2, but we still have a carry value. So if the carry value is not equals to 0, that means there are still some carry need to add. We can just generate a new node from this carry over value. And we add this new node to the linked list, result linked list, and move the L3 pointer to this new node. And finally, we need to return the head of the result linked list. It's very simple to do here. Just return a dummy.next. So you see the benefit of introduce a dummy node here. So by introduce a dummy, we can just use a dummy.next to get the head of the result linked list. Okay, we finish our code. So before we submit, we can walk through this process. We introduce a dummy node at the beginning used to link to the head of the result linked list for convenience. And at the beginning, the L3 pointer starts from the object dummy node refers, and we have a carry variable to store the carryover value. So we handle the situation when both linked list 1 and linked list 2 have a remaining list node. So we add their value together to get a digit value and get a carry, and add to the new node to the result linked list. And we handle the situation when there's only L1 or L2 has a remaining list node. We just add L1 or L2's value to the result, and add to the sum. We generate from that sum to generate a new node, and add the new node to the result linked list. And we also handle the situation when both linked list 1 and linked list node we work through and find no more linked list nodes anymore, and we just need to add a carryover value. If there's a carryover value left there, we generate a new list node and we add to the linked list. So, and finally, we return the head of the linked list, result linked list. So here, let's click the submit button. If there's a, see what's the result. Okay, very beautiful, accepted. So the code is very correct. So you should see the whole process, how we do the addition operation on the linked list. So we successfully do this imitation game to imitate the addition operation on the linked list. So this is all about solve this problem at two numbers. I hope you you can learn from this video not only how to solve this problem, but get some more knowledge about the linked list and learn and improve your coding skill and be more confident in solving coding problems and the coding exercise. So this is all about this video. I'm GoodTecher. You can find me from my own website www.goodtecher.com. I write articles about solving problems. You can communicate with me here. And besides, if you have any comments, any suggestions, any ideas, please just leave a comment under this video. I will take a look at to keep improve my video tutorial quality. And if you want, I welcome you to subscribe to my channel on YouTube. And if I will keep solve the coding problems and keep uploading some new video tutorials. If I upload it, if you subscribe, you will get a notification, and we will make progress together. So just do it. Okay, that's all about it. Thank you for watching. This is GoodTecher. Bye.